Welcome to the brand new section of this course, Parallelism and Concurrency. Now let's move on to the video, Executing Sleeping Time and Exploring Threads. Let's start with putting a program to sleep for specific amounts of time. Let's take a look at the entire code example. We will define a short program that just puts the main thread to sleep for certain amounts of time. Now we will understand the code. Let's first include all the needed headers and declare that we'll use the standard and Chrono literals namespaces. The Chrono literals namespace contains handy abbreviations for creating timespan values. In the main function, let's immediately put the main thread to sleep for 5 seconds and 300 milliseconds. Thanks to Chrono literals, we can express this in a very readable format. The last sleep statement was relative. We can also express absolute sleep requests. Let's sleep until the point in time, which is now plus 3 seconds. Before quitting the program, let's print something else to signal the end of the second sleep period. So it's time to compile and execute the code. Go to the terminal, type in the command for compiling the code. We have compiled successfully. Linux, Mac, and other Unix-like operating systems provide the time command, which accepts another command in order to execute it and stop the time it takes. Let's execute it with typing time followed by /a.out. It may consume your time. Here is the required output. Running our program with time shows that it ran for 8.32 seconds, which is roughly the 5.3 and 3 seconds we let our program sleep. When running the program, it is possible to count the time between the arrivals of the printed lines on the terminal. Next, we will be starting and stopping threads. Let's take a look at the entire code example. So go to the Atom editor, then open the ex2 directory, and inside that, open the threads.cpp file. This is the entire code. Here, we will start multiple threads and see how our program behaves when we unleash multiple processor cores to execute parts of its code at the same time. Let's understand the code. At first, we need to include only 2 headers, and then we declare that we use the standard and Chrono literals namespaces. In order to start a thread, we need to be able to tell what code should be executed by it. So let's define a function that can be executed. Functions are natural potential entry points for threads. This example function accepts an argument, I, which acts as the thread ID. This way, we can tell which print line came from which thread later. Additionally, we use the thread ID to let all threads wait for different amounts of time, so we can be sure that they do not try to use cout at exactly the same time. If they did, that would garble the output. Another video in this section deals specifically with this problem. In the main function, we can, just out of curiosity, print how many threads can be run at the same time using thread hardware concurrency. This depends on how many cores the machine really has and how many cores are supported by the STL implementation. This means that this might be a different number on every other computer. Let's now finally start threads. With different IDs for each one, we start 3 threads. When instantiating a thread with an expression, such as thread t of f, x, this leads to a call of f of x by the new thread. This way we can give the thread with param functions different arguments for each thread. Since these threads are freely running, we need to stop them again when they are done with their work. We do this using the join function. It will block the calling thread until the thread we try to join returns. As you can see, we call the join method on T1 and T2. An alternative to joining is detaching. If we do not call join or detach, the whole application will be terminated with a lot of smoke and noise as soon as the destructor of the thread object is executed. By calling detach, we tell thread that we really want to let thread number 3 continue running, even after its thread instance is destructed. Before quitting the main function and the whole program, we print another message, thread joined. So now it's time to compile and execute our code. Go to the terminal and navigate to the directory ex2. Next, we will clear the screen using the reset command. After that, type in the command for compiling the code, and don't forget to add the p thread, or else it will give a warning. After the successful compilation, let's execute it. Here is the required output. we can see that my machine has 1 CPU cores. Then we see the hello message from all the threads, but the bye message is only from the 2 threads we actually joined. Thread 3 is still in its waiting period of 3 seconds, but the whole program does already terminate after the second thread has finished waiting for 2 seconds. This way, we cannot see the bye message from thread 3 because it was simply killed without any chance for completion and without noise. So here we have come to the end of this video.